Welcome back, learner. In previous classes, we were studying about simplification of Boolean expression using Karnaugh map. So we come to know about two variable K map, three variable K map, four variable K map, and their simplification method. So we left on this prime implicants. So what are these prime implicants? So as per definition, a prime implicant is a product term obtained by combining the maximum possible number of adjacent squares in the map. Basically, prime implicants are the product terms which cover maximum number of min terms or max terms. So, the prime implicants of a function can be obtained from the map by combining all the possible number of squares. So those solutions, those product terms are the basic are essentially prime implicates. However, within that there are essential prime implicates. We will see what are those. Let us see an example. An example is given here that f is a function of variable a b c d, which is equal to summation within bracket 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, and 15. So these are the min terms at which the function gives value 1. Means function gives true value on this min terms. So this is 4 variable. So we need 4 variable k map. So if we can see in figure 3.11, we have a 4 variable k map. So let us see on this side, this is AB and this is CD. So you can assume that this is A bar, B bar, A bar, B, A, B, A, B bar. Similarly here, C bar, D bar, C bar, D, C, D, and C, D bar. So this is as per your gray code. And the locations of these midterms are designated as M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15. So this we have already covered. Now as per the statement of the problem, we fill up these midterms wherever f is equal to 1. So we come to know f is equal to 1 at this 0, 2, 5, 7, 8, 10, 13, 15. Now, what is happening here? We try to make the maximum possible number of adjacent ones. It may be, say, since it is a 16, so maximum possible number of ones may be group of 16 ones, group of 8 ones, group of 4 ones, and pair. And if it is not making, then we leave like that. So here we can see these four are in adjacent, these four ones like M5, M7, M13, M15. So we can make a quad here with group of four ones. And if we fold this K map, so all corners will come in adjacent. So we can make a group of 4 one here also. So 2, basically it becomes here 2 uh, to quads. So based on that, we can find out the solution. So this becomes here B, D, B bar, D bar. However, if you see in this figure B, here it is a matter of essential priming implicants. Let me describe here. Basically, these questions which is written here of f is equal to 0, 2, 3, 5, 7. Let me write here. F is equal to summation 0 to 5 7, 0 to 5 7, then 8 9 10 11 13 15, 8 9 10 11 13 15. So for this function, if we implement, so we come to know there are not there is not a single way of minimizing this Boolean expression. There may be more than one, and fortunately for this particular problem there are four ways of minimizing. So number one is this one, number two is this one, number three this one, number four is this one. So there are four ways, or four way of minimizing this sorry, of this Boolean expression. But you see, and as far as correctness is concerned, all are correct. All are correct. That is why we can say the solution of Karnaugh map is not unique. This is number one. Number two, here, if we observe clearly, so we can see that BD plus B bar D bar, these two terms are common in all four kinds of solutions. So that is why it becomes essential. Essential prime implicants. However, any of these two, this CD plus AD, you can take. So this is means essential prime implicants. That means solution doesn't exist without taking consideration of these terms. So that is why it is a essential prime implicants. Now, five variable K map. So map for more than four variables are not as simple to use as map for four or fewer variable. A five variable map needs 32 squares, means 2 to power 5 is equal to 32, and six variable map required 64 squares. When the number of variables become large, the number of squares becomes excessive, and the geometry for combining adjacent squares become more involved. So and map for more than four variable are difficult to use, and we will not consider here. This is what, however, one or two example I will take up later on. So let me take an example uh, of solving a key map. Let me take any known value so that you should able to verify. So f is equal to 1. I will take this function f is equal to summation 1 2 3 5 7, 1 2 3 5 7. So I will move to this Jamboard. Yes. So we have taken a function. So function f a b c, three variable for simplicity, and the questions are 1 2 3 5 7. Summation 1 2 3 5 7. 1 2 1 2 3 5 7. Yeah, good. So we know how to solve with the help of Karnaugh map. For simplicity, for ready reference purpose, let me write here so that you should know. So this is three variable key map. So I will take here a bar a, b bar c bar, b bar c, b c, b c bar. This is 1 0 1, then 2 3 4 5 6 7. So as far as simplification is concerned, we can make this a quad, and in order to include this last one, we can make a pair. So solution becomes here f is equal to, for this we can say this is c, and for this pair is equal to a bar, and row wise, from row we can take a bar common, and column wise this bc and bc bar, these two columns has b as a common. However, C and C bar cancels. So answer is this one, C plus A bar B. This answer we know. Now we will apply another method of simplifying Boolean expression called tabulation method. It is called tabulation method or Quinn-McLachlan method. So what is its method? First of all, we have to, step number one, we have to convert this decimal number into its equivalent binary number. So 1 will be 0, 0, 1, then 2 will be 0, 1, 0, 3 will be 0, 1, 1, 4, 5 will be 1, 0, 1, and 7 will be 1, 1, 1. This is number one step. Number two step, based on the number of ones present in each digits, we have to classify. So number of one is here. So I will take group 1. This is also group 1. We can assume this is group 2. This is group 2. And we can tell this is a group 3 because 3 number of ones are there for simplicity purpose. Okay. So this is 2. Now we have to arrange in group wise. So I write here group. Now I am going to make a table. So here I will write a group, and this side I have to write the variables containing Boolean expressions A, B, C. So group 1 contains this number. You can say here number. This is 1, and 1 is written like this 0, 0, 1. And second, in same group, another number is that is 2. So we can write 0, 1, 0, in which also number of ones is only 1. So in group 1, 2 numbers are there. Then I will write here group 2, and in group 2 we have 2 numbers again, that is 3, and we can write 3 like this 0, 1, 1, and 5, 1, 0, 1. So I think you are able to understand that we are grouping this number as per number of ones present in this digit. Okay, so we have covered group 2. Now group 3. So group 3 we have only one number, that is the 7. So 7, and we write here 1, 1, 1. So I think up to that uh, one is able to understand. Okay, I think this is not zoom out. Now next stage, what is that? Now simplification terms comes. How to simplify? So we write here first again numbers, suppose, then here ABC, ABC, and the method of minimizing this expression is like that. First of all, we consider this number like first member in group 1 should be compared with the member of group 2. Member of 1, member of group 2. So member of 1 are 1, and member of 2 are 3 and 5. So we have to compare, but there is a condition that they can be compared if there is only one bit change. If there is more than one bit change, then it cannot be compared. So let us see 1 and 3 whether they are comparable by comparing bit by bit. So this is 0 here, this is 0 here, 0, 1 means one bit change, and this is 1, this is 1. It means there is no change here. So overall only one bit change is there. So it means they satisfy the condition. So we can write here 1 and 3 and try to compare, and after comparing try to write the minimized expression. So 0 is compared to 0, it will be here, 0 and 1 will be cancelled. Let us put dash and then 1, 1. So 1 and 3 we have compared, so we put here check mark. Then now 1 and 5 is comparable or not? So we can see that 1 and 5 both are comparable because only one bit change is there. So this is dash 0 and 1. So and now 1, 3 and 1, 5 is over. Now I will take 2 and try to compare the member of group 2. So 2 and 3 are comparable. I think they are comparable. So 2 and 3 I can write. So 2 and 3 will be 0. Then this will be 1 and this will be dash 2, 3. And 2, 5. In 2, 5 we can see 0, 1, one bit change, 1, 0, another change. So it is there is a 2-bit change. So it is not permissible to compare 2 and 5. So we leave that one. Now 1 step we have completed. Now I will move to next. But procedure is same. Means group member of group 2 should be compared with the member of group 3. Means 3 and 7. Whether they are comparable. If yes, then we write here minimize term. Otherwise we will leave. So 3 and 7 we look here. One bit change is there only. The 3 and 7. So it will be dash 1 1. Now 5 and 7, yes, 5 and 7 also can be compared. So we can write here 1 dash 1. Elements of group 1, group 2 and group 3 are compared and reduced this one. Now moving to next step, if permissible. It is like that. If this one. Again the same procedure. Here suppose we write here number and then A, B, C. So 1, 3 is comparable to 3 and 7. So we check this is 0, this is dash, this is dash, this is 1, 1, 1. So there is a more than one bit change. So 1, 3, 5, 1, 3 and 3, 7 cannot be compared. Now moving to 1, 5 and 3, 7. Okay, let us check another one. 1, 3 and 5, 7. So again 0, 1 dash 1, 1. Yeah, it can be compared. I think 1, 3, 5, 7. Let us finish this one first. So this can be here 0, 1 will be dash, again dash, then third one is the 1. Now moving to this 1, 5, 1, 5 with 3, 7. So 1, 5, 3, 7 is comparable because only one bit change is there. So 1, 5, 3, 7. So we can write here dash, dash, yeah, dash 0, 1. So it will be dash 1, 1. So it will be 1. So this and this means 1, 5, 3, 7 has been compared. Now the next one 1, 5, 5, 7 is comparable. So we see here one bit change is there dash 1, 0 dash. So two bits changes are there. So we will not compare 1, 5, 3, 7. Now moving to 2, 3, 3, 7. So 0 dash 1, 1 dash 1. So more than 2 bit changes are there. So it is not comparable. Means 2, 3, 3. Let us see 2, 3, 5, 7. So 0, 1, 1 bit change, 1 dash 2 bit change. So it is also not comparable. So now we see 2, 3 is not comparable with anyone. So we leave like that and let us put here cross mark, so that we can write the answer later on. So now let me write the answer final one, because now there is no further scope for reducing the min terms. So let us see what is the answer here. Answer from here we can see this is dash dash 1 dash dash 1. So it is only one thing. So we can write here this is C, because C is 1. And now going back, which min term was not covered or not ticked, like this is uncovered. So we see this is 2, 3. 2, 3 is nothing but we can write here 2, 3 means here this is 0 is A bar, and this is 1 means B, and C1 is the dash. So we will not include that. So A bar B. So we write here A bar B. So you see, with the help of tabulation method, we also got the same answer, C plus A bar B. And the same answer we got through the Karnaugh map. So this is the method through which, this is another method, that is the tabulation method through which we can simplify. The important advantage of simplifying Boolean expression with the help of tabulation method is that it is compatible with the computer, one thing. Second thing, any number of variable it can handle, and it is an iterative process. However, Karnaugh map is a graphical method, visual method, where computer is not so efficient. However, tabulation method is an iterative method and efficient also, because it can take care of any number of variable. However, in keymap, after 4 variable, it is unmanageable. Up to 5 or 6, one can manage with great difficulty. But after 6th, it is impossible, almost impossible to visualize or for a human being. So there, tabulation method comes into picture as an exceptional solution. So learner, I think you could get what is the method. So what I will just repeat in 1 minute. In tabulation method, first of all, the given minterms, that is function 1, 2, 3, 5, 7 is converted into binary number, and then based on the number of ones present in each binary number, we classify like group 1, group 2, and group 3, and then we we put in a particular order, like here this number, this is grouping, and then ABC, and then try to compare, means group member of group 1 should be compared with the member of group 2, but there is a condition of comparability, means reduction. There should be only one bit change, then only it can be compared, like 1 and 3 was comparable, only one bit change was there, that is why it has gone to the next stage of this table, and so on. And after that, uh, please mind that in on your notebook or paper, please put this tick mark, so that you should know these midterms were covered, and the midterm which is not covered, put a cross mark, so that whenever you are writing the final solution, you can consider those uncovered midterms. In this case here, 2 and 3. So you see, our answer matches with Karnaugh map as well as with the tabulation method. So with this, let us conclude this session. Thank you so much. See you soon.